Hello everyone and welcome to the week 9 of NPTEL course in pharmacognosy and phytochemistry. In the previous session, we saw what are resins. So just to recollect, resins are substances which are produced by plants, sometimes physiologically, sometimes as a result of injury. They differ from gums and mucilages in a way that they are not carbohydrate but more complex mid-polar compounds which are generally polymerized out of terpenes and are often oxidative degradation products of the same. So let's see some examples of resins in this session. In this session, we will be discussing about two resins, colophony which occurs from pine and benzoin which occurs from the styrax species. Now colophony is a resinous compound which doesn't contain a combination, whereas benzoin is categorized as balsam, that is it is rich in balsamic acids. So let's start with colophony. So colophony is actually a residue. As you can see here, it's a nice transparent to translucent depending upon how old the sample is. So it's a nice yellow amber colored solid which is transparent to translucent and is obtained from pine trees. So it's basically, when you say colophony, initially it's an oleoresin which is obtained from the pine trees, and then when you distill off the oil from oleoresin, when the oil is removed out, you just get the plain resin, and that's what precisely is colophony. The oleoresin is often referred to as rosin. Now all of this is obtained from the pine species belonging to Pinaceae family, but majority of the resin comes from your Pinus palustris. Now coniferous or pine forests geographically occur in North America, Northern Europe and in the Himalayan belt of India and Pakistan. So that's chiefly where you get your pine resin from. Now you get two type of pine resin. One resin which is called as wood rosin. So what is done is, you might have seen sometimes during the Christmas season when the coniferous trees are cut off, you get stump. There's some resin which is exuded from the wood part of it, and that is what is referred to as wood rosin, and wood rosin mostly is obtained from southern pine stumps. Whereas if you see gum rosin is generally when you make external incisions, when the tree is not cut directly but tiny incisions are made on the external surface, and then from that continually you keep on eluting what is called as the resinous exudate from this plant. So mostly this is done from pine species such as Pinus palustris and Pinus scarabea trees. Now let's see how do we prepare it. Now for pine trees, generally mature trees are taken, and these mature trees are often injured. Now you will ask, like, if colophony or pine resin is a normal physiological resin, why are the trees injured? It is said that when you injure a pine tree, more and more or the resin yield goes on increasing. So injury increases the amount of resin which is present, and in order to get a good yield, people often injure the tree. So the trees are injured, enhancing the resin content which is already been present, and then you make a slight slit or what is called as sloping cavity. So say for example, this is your tree, a sloping cavity is made, okay, and as it slopes, what is done is it's slightly put in or made slightly more deeper, okay, so that all those resinous ducts are exposed. Now what happens is, when the cut is made on a tree trunk, the oleoresin starts exuding out. Now once it starts exuding out, it will stick to the tree. So what people do is, imagine something like a blade. So they take a copper or a metal plate and fix inside it. Now what is going to happen is, this is something like a tray. So whatever resin is exuding out will get exuded and will flow down. Okay. So you generally keep a vessel or something to collect it if it is in the liquid stage, which is initially it happens, and later on it solidifies. So you need not keep anything there. So it solidifies and you get on this metal plates amount or a good amount of oleoresin being accumulated. Now this process is continued and the oleoresin is extracted till the autumn season. So right from the winter to the autumn season, for many weeks this resin keeps on exudating and it is extracted. Once extracted, what is done is this resin is taken and put in water. Now this resin is almost a little bit heavier than water, so it sinks and then the water is heated. So when the water is heated, as we saw, this process we called it as hydrodistillation. Do you recollect, in volatile oil, hydrodistillation was one of the method which was used to extract the volatiles. So this oleoresin now is heated in water, undergoes hydrodistillation. As a result, whatever the volatile oil, like this contains turpentine like elements, pinene, turpentine, terpineol and so on. So this volatile elements distill off along with the water, and what you get in the end is what is called as a pure resin. So this impurities also, as they loosen up, they start floating in because they are wood particles. Wood particles don't sink in. So impurities are skimmed off and this on heating forms a very sticky adherent mass. So this sticky adherent mass is separated, dried and used for or used as what is called as your colophony. So this colophony on our preparation or on drying appears like a pale yellow to amber, as we just saw, translucent fragments. Now if you go on heating it, you will see that these are solids which are polymeric in nature, something like your plastic. So what happens when you heat plastic, it kind of melts and fuses. You will see a very similar behavior with colophony. Now because it is a what to call it as a polypropanoidal compound, or it's a resinous compound, it eventually burns at 100 degrees Celsius, initially melts, fuses and burns with a very smoky carbonaceous film. So this is very typical of resinous compounds, and what happens is, if at all you tend to heat it in presence of water, because of the oil content or because of the resinous content which is insoluble in water, it forms a little milky white solution. So this is also something which is very typical to pine resin. Now when you take crude rosin, it's already containing oil. Now this oil imparts more softness to the rosin. Now because of it is more soft as compared to your colophony, it melts to a very soft nice mass, very soft like your dough, and fuses and forms a sticky mass like a film. So you can actually take a spatula and spread it across. So it forms that soft kind of mass, and because of presence of oil, it has a turpentine like odor. Now this colophony is rich in acids, basically your terpinaceous acids, or when we classified it, we called it as resin acids. So colophony is very rich in the resin acids, and as a result, if you titrate it, you will get a very high acid number. So for this particular resin, the acid number should not be less than 150. If the acid number is less than 150, that indicates the resin acids are missing and something else which might be more synthetic is added, and that might be an indicative of adulteration. In terms of its density, it is just little heavier than that of water, and as a result it sinks. Now taking into account its polymeric nature, you will see that this is more towards the lipophilic side, not towards the water soluble or to the polar side, and as a result it dissolves properly in your ethanol, benzene, ether, that is your diethyl ether, glacial acetic acid, which is little organic in nature compared to your acetic acid, it disperses very well in oils and it dissolves nicely in caustic alkalis. The reason caustic alkalis are aqueous, but they are basic in nature. When you see this particular component of resin, it is rich in acids. So these acids react with bases to form salt, and that imparts it a very nice solubility in caustic alkalis. But when you take an example of glacial acetic acid, the solubility is predominantly due to the organic nature of glacial acetic acid and not due to its acidity. Now coming to the chemical composition, the chemical composition of your pine resin, that is your colophony, is mainly attributed to acids or often referred to as resin acids. A good example of resin acid is your abatic acid. Now you will see few other acids which are very similar here. So if you see abatic acid, if you see your palistric acid, and if you see your neoabatic acid, they are very similar in structure. But what is the little or subtle difference between the two is the placement of the double bonds, which is slightly different in all of three, whereas the functionalities or functional group remains nearly the same. So it's an interesting phenomenon to be observed. So what happens is, so you have what is called as pimaric acid and palistric acid. So pimaric acid and palistric acids are chief acids which are present in the raw resin. We often refer to that as rosin or oleoresin. So but when you heat it, remember in the processing we heated it. So when you heat it for the process of removal of oil, it is said they undergo rearrangement. So your pimaric, levopimaric acid, palistric acid all undergo rearrangement. Now why am I emphasizing on this? So if you see the abatic acid content of raw resin, that is rosin, abatic acid is present just to the extent of 7%, whereas if you see your pimaric, levopimaric or palistric acid, together they make up more than like 50% of the resin. Now after steam distillation, this undergo rearrangement. They are structurally very similar. So what has to change there is just the placement of double bonds. So after steam distillation, there's a lot of rearrangement happening, and after steam distillation all your pimaric acid, leopimaric acid, palistric acid interchange, and what is going to happen is your abatic acid concentration changes from 7% to 40%, whereas your pimaric acid concentration changes from 40% and goes down to as low as 5%. So abatic acid is born during the process of steam distillation at the expense of pimaric acid. Apart from that, you have your saponic acid, dehydroabatic acid, dihydroabatic acid and other abatic acid derivatives. So all of these acids put together are classified or called as your resin acids, and they make up more than 90% of the weight of resin. Now apart from that, the other part of resin is like a sticky matter or inert long chain polymerized matter, which is generally thought to be very unreactive. Now not only that, if you take just pure abatic acid, if you heat it to 300 degrees Celsius, your abatic acid undergoes further rearrangement to form what is called as neoabatic acid, as shown here. You can see a little transformation in the double bond. This switches to here and this switches to here. So it's like this goes here and this goes here. So this is what happens when you heat it, and from your pimaric acid, first abatic acid is born, heat it further, from abatic acid you will get your neoabatic acid. Apart from that, it also contains a little bit of what is called as unsaponifiable matter, which is rich in hydrocarbons and high molecular weight alcohols. Now coming to a chemical test, because it contains mostly your resin acid, it gives you tests very peculiar to this resin. Now when we previously sought examples of different class of compounds such as alkaloids, flavonoids or anthraquinones, we had typical distinguishing tests like Bontrager's test for anthraquinones or Dragendorf test for alkaloids. If you see resins, there is no specific test or there is no test which can be generalized to all resin class. So here, depending upon what class they contain, what functionalities they contain, every resin example will have its own unique characteristic chemical test. So for pine resin, what you can do is you can take the colophony resin, just triturate it, powder it and dissolve it in acetic anhydride and sulfuric acid. You will see a good purple coloration because of the presence of terpenoidal compounds. Not only that, because of the presence of resin acids, if you take this colophony powder, disperse it and nicely dissolve it in alcohol, it solubilizes. Treat it with your normal litmus paper, you will see that your litmus, that is your blue litmus, will get converted into red, indicating its acidity. Now there is one test which is very specific for colophony, and that is what is called as your cupric acetate test. Now what is done in this case is you take your colophony and extract it with your PET ether. Most of your resin acids get extracted in your petroleum ether. Generally the 60-80 fraction, that is the amount of fraction of petroleum ether which boils between 60 degrees Celsius to 80 degrees Celsius is what is taken. Now solubilize it well, and if you want it, gently warm it, but don't heat it because it's a very low boiling organic solvent that you're taking. Okay, so even if you're heating, don't use direct flame, just use a mild water bath or gentle heat. So once when you're done this, you can filter it, take the petroleum ether layer, and to that you will add your 0.1% aqueous cupric acetate solution. Now when you add that, what is going to happen is the copper in that solution is going to react with abetic acid and resin acids, and as a result this copper is absorbed by this to form what are called as cupric salts. So you will get your cuprate salt of abatic acid, which shows a typical emerald green color against cupric acetate, which is more of a bluish coloration. So presence of emerald green coloration is indicative of presence of abatic acid, and that's how you confirm the sample given to you is colophony. Now where do you apply all this? Colophony being a very pinaceous resin forms a nice films and stiff films, to be more precisely, and as a result it is used in plasters, it is used in ointments. Wherever you want adhesive, you get it there. So even for your wax based depilatories where you want a good adhesive effect, or even in adhesive plasters it is used. It is used in printing inks where you want to have little viscosity, varnishes, sealing or sealants, linoleum, or even it is an interesting ingredient of soldering flux where you want to clean the other debris and wash out. So that soldering flux also formula also contains little amount or little bit of your pine resin. Apart from that, when you want water repellent thermoplastic floor tiles, this resin is being molted, dissolved in solvent and poured, and it gives you a nice film over the tiles to get your thermoplastic floor. Not only that, it's used in cements, it's used in soaps because we saw it's acid, so it will react with alkali to give you soap. Wood polishes for its film forming properties, it's used in paper sizing solutions, it's used in plastics, and even fireworks because it gives you a waterproof and a very tight binding for the material or the explosive material. It is used to even waterproof your papers or paperwork such as cardboards, and in a pharmacy it is more used as a stimulant and diuretic. Even for the people, those who are interested in music, if you know the violin strings, they are made they are made up of, or especially the bow, if you go to see, they are made up of horse hair. So for that horse hair to give it a good friction, so that the metal wire can nicely make sound with it. It is often treated with your rosin. So even your violin, people treat the bow with horsehair bow with rosin and use it for playing instruments. Now let's move on to the second drug, and that's your balsamic drug, and that's your benzoin. Now there are two type of samples which are available in market when it comes to benzoin. One is the Sumatra benzoin and one is the Siam benzoin. As the name indicates, Sumatra benzoin comes from the Sumatra province, which is located more in Indonesia, whereas Siam is located in Thailand. So there is a little species difference between these two plants. So Sumatra benzoin is obtained from the trees, that is from Styrax benzoin and from Styrax parallelonensis, whereas your Siam benzoin is obtained from your Styrax tonkinensis. Both of them are Styraceae family member, but what is difference is your speciation that has occurred between your Indonesian plants as well as the Thai plants. So geographically, Sumatra benzoin is found in the Indonesian belt, that is your Sumatra, your Java and Borneo islands, whereas Siam benzoin occurs in the little Thai area, that is Thailand, Vietnam, and some cases even in Laos. So if you see both of these benzoins, you actually have what are called as benzoin forests. That means the benzoin trees are specifically cultivated to get this balsam. So in the Indonesia or even in the Siam province in Thailand, these trees are abundantly cultivated. Now they are cultivated, and right from the age of 8 years till 20-25 years, they give you a good amount of resin. So these plants are allowed to grow to more than 8 years old, and once they are more than 8 years old, what is done is a small triangular deep incision is made into the bark. Now we saw earlier that the pine resin was an example of physiological resin. Whereas when we come to this example, benzoin is not a physiological resin, it's a pathological resin. What does it mean? That if the plant is not injured, you will not get the resin. So if you just cut the tree the same day, you will not get it. But if you injure the plant, gradually the plant will start the process of producing resin. So this plant produces traumatic resiniferous ducts only after you produce or injury to it. So injuries are made in a small triangular formation. So once the triangular formation is done, the little bark is removed off, and then you will see that the plant starts exudating this over a period of time. Now the initial amount of resin that comes out is little yellow. So the first crop is not really white or pristine white, it's a little yellow in color, and it appears as a tiny teary material, so it forms blobs or tears. Now when you do a second tapping of this plant, one more incision is made. This time, rather than a yellow resin, you will get a milky white resin coming out. That's more of a resin of your commerce. Now it is said that throughout its age, right from 7 years till as long as you are tapping it, on an average a plant might yield somewhere between 1 to even 10 kg of drug. So that's really profitable, and that's the reason this forests are kept. So they go on tapping till the resin no longer is white. So in fact it is said that after multiple tappings, the resin starts appearing darker or yellow. So because it is not a physiological resin, it's pathological resin, every time you want to get the resin out of the plant, you have to injure it. So injure it once, then after 5 centimeters the another triangular incision is made. From that you are removing the resin. So once one side of the tree is covered completely with the bruises, they start making bruises on the other side. And once both the sides are covered, that plant is left alone. So that is the time it ceases to produce or produces a really dark color resin, which is no longer useful. But more or less it is a habit that all of this resinous material is pulled together, mixed and then dried. Once dried, you get in market what is called as commercial or balsamic resin. So if you see the Sumatra benzoin distinctly is more grayish in color, and if you see the internal side is little grayish or milky white as compared to the external side. So they are like variable sizes, they might be big, they might be small, they are translucent, brittle, irregular masses, internally whitish in color, externally grayish, and a little gritty texture. So when you're consuming it, they're little gritty and little acidous because they contain balsamic acids. So that balsamic taste is very close to that of storax, and a very aromatic, like a organic taste you get of those balsamic acids. Now coming to your Siam benzoin. Siam benzoin is the one which occurs in the Thai province. It is said that as compared to the Indonesian or the Sumatra one, Siam benzoin is more of yellowish brown in color, but internally that's also whitish. If you see the smaller tears, they are much darker than the larger chunks, and if you take them and you start chewing them, they form a little plastic like or chewing gum like masses. So they have a good amount of what is called as resins or resins that makes it more chewy. As compared to your Sumatra, Siam benzoin has more nice aromatic or vanilla like fragrance. Now coming down to the chemical constituents, if you see Sumatra benzoin is rich in free balsamic acids, that is your cinnamic acid and benzoic acid. So cinnamic acid is your phenylpropanoid derivative. You can see here, this is your cinnamic acid, and instead of this, if a COH is attached here, we call it as benzoic acid. So cinnamic acid, benzoic acid totally make up to almost 16%, and along with them their ester derivatives make up to little more. Now going to the major component of Sumatra benzoin, it is said that the major components of Sumatra benzoin come in from terpenes, especially triterpenes belonging to the beta-amyrin category. So much so that if you put total terpene put together, the terpenoidal content of benzoin goes to as high as 90%. So it contains triterpenes such as oleanolic acid derivatives. So you have 19 hydroxyoleanolic acid, 6 hydroxyoleanolic acid, you have esters like cinnamyl cinnamate or phenylpropyl cinnamate, or even the phenylethylene derivatives. Now coming down to your Siam benzoin, which is the Thai variant, you will see more of a esters coming here. So one particular ester, which is your coniferyl benzoate. So what is coniferyl benzoate? So it is benzoic acid, you can see B, this is the benzoic acid which has formed ester with coniferyl alcohol. So coniferyl alcohol is now a phenylpropane derivative, but this time it's not an acid, it's an alcohol. So coniferyl alcohol plus benzoic acid gives what is called as coniferyl benzoate, and is the major component of your Siam benzoin. It also contains benzoic acid, triterpenes, majority your CRSinol, and traces of vanillin. Now one point to be noted is both of them contain vanillin, that is your aromatic principles of vanilla, but in Sumatra benzoin the free acids, especially the balsamic acids, their aroma and taste is more spicy, and as a result it completely masks the vanilla odor. Whereas Siam, since most of the balsamic acids are esterified, the vanilla aroma becomes more predominant, and as a result your Siam benzoin gives you more of a vanilla like fragrance. A little difference between the two, if you see your biological sources, Sumatra comes from your Styrax benzoin or Styrax paranoneris, whereas your Siam comes from your Styrax tonkinensis. Geographically, this is more predominant, that is Sumatra is more predominant in the Indonesian region, whereas Siam is more predominant in the Thai, Vietnam, Laos region. If you see chemical composition, Sumatra is more rich in balsamic acid, especially free balsamic acid, and contains your triterpenoidal compounds, whereas if you see your CM benzoin, it contains chiefly your esters such as your coniferyl benzoate. Now if you see the alcohol soluble extractive value, it is little less for Sumatra, that is not less than 75% in terms of limits, whereas if you see a CM, because it contains coniferyl benzoate as a chief one and some other esters, on the alcohol soluble content goes to as high as 90%. In terms of appearance, this is a little grayish brown, whereas your CM appears to be yellowish brown. Coming to the chemical test, your Sumatra benzoin, because it is rich in benzoic acids. So when you see your Sumatra benzoin, what happens is Sumatra benzoin contains chiefly your benzoic acid and cinnamic acid. Now this cinnamic acid will get oxidized in presence of potassium permanganate. Now this will kind of cut it and oxidize it to produce your benzaldehyde. Now benzaldehyde is the compound which is responsible for giving aroma of almonds. So if you get that, like bitter almond aroma or benzaldehyde aroma, it is chiefly due to the presence of free cinnamic acid reacting with your potassium permanganate. On the other hand, because your CM benzoin has your coniferyl benzoate as compared to your cinnamic acid, the aroma is hardly there or not so significant. But there's another test which can be used there. So if you take your CM benzoin and digest it like for 5 minutes with ether, so that a complete extraction happens, filter it, and to the filtrate, if you treat it with sulfuric acid, a deep purplish color immediately develops. Now this in Sumatra benzoin, instead of deep purplish, is more of a red brown color. So that color change can significantly tell you whether it's a CM and Sumatra. One more test which can be used is something which can be used to detect your coniferyl benzoate, and that's your ferric chloride. Now if you take your benzoin, treat it with ferric chloride, a green coloration is produced, especially with CN benzoin. The reason being because it's rich with coniferyl benzoate and that reacts with your ferric chloride to give you a green color complex. Now Sumatra doesn't have coniferyl benzoate, and as a result this test is absent or negative for this drug. Now one more thing also you can try is, if you know this balsamic acid, cinnamic acid or even benzoic acid, they have good tendency to heat up, sublime, and then when exposed to a cooler surface they kind of cool down and crystallize. So if you take your Sumatra benzoin powder, heat it gradually and keep an inverted funnel which is slightly cooled. So what is going to happen is, this fumes which contain cinnamic and your benzoic acid will heat up. They will gradually condense on this inverted funnel, and you will observe a tiny crystals over a cool surface. So this is also one thing which you can observe in your Sumatra, which will be seen missing in your CM. Now coming down to the applications, chiefly because of its benzoic acid content. Now if you see benzoic acid, especially if you convert it into sodium salt, sodium benzoate, it is a nice preservative. So this is antibacterial agent. It is used as a topical protectant. In some cases it is even used in gargles and mouthwashes. Not only that, inhaling the fumes which are containing traces of your cinnamic and benzoic acid is thought to be a good expectorant. So even a gentle whiff of benzoin is given for people suffering from cough and cold to be used as an expectorant. Not only that, your cinnamic acid derivatives have been used as protectants, sunscreen agents and antimicrobial agents. So they have a very good application as organic sunscreen agent derivatives. Not only that, also as a topical protectants. And yes, definitely your sodium benzoate is abundantly used, and plant-based sodium benzoate is something which we look for in most of our cosmetic preparations. So these are few applications of your benzoin. So today we studied two drugs, colophony and benzoin. Colophony, a good example of resin, whereas if you see your benzoin, it's a good example of balsam containing drugs. So if you wish to know more about these two plants, you can refer to this references, and thank you everyone for your patient listening.